So again, we're solving by elimination. All right, so my first priority is to get the same number, different sign with one of my two variables, solving by elimination. So if I'm looking here, I can see that both of these y's have a coefficient of 1. The problem is they have the same sign. Okay, so if it's me, I'm going to take this bottom equation and multiply by a -1, because when I do that, I change every sign that I see. I'm multiplying by a -1, and this will become a negative y. Now I'm ready to eliminate my y's. So if I go through and I multiply it by a -1, this becomes a positive 2x, this becomes a negative y, and this becomes a positive 17. Now I can add these together. Again, we're solving by elimination, so we're adding the two equations together. All right, so I've got 6x plus 2x. That gives me 8x. Okay, and then I've got a positive y, and I've got a negative y. So when I add those together, that's all right. When I add those together, those are going to be eliminated. Elisha, you writing this down? All right, so again, what I'm working for is I'm working to eliminate, hint, hint, why we call it the elimination method. I'm working to eliminate one of my variables. So I've got a positive y and a negative y. I add those together. If you've got $1, you subtract $1, those go away. So we have eliminated that variable, which is, again, what we're trying to get. And then now I'm adding 39 and 17. Add those together, I get 48. No, sorry, 58. Hello. So again, what I'm working for, guys, is I need the same number but a different sign in either one of my two variables. It doesn't matter. Same number, different sign in either one of my two variables. So what my first step was is I multiplied by a -1 here, because what I was trying to get is a positive y. That means that this needs to be a negative y. That way I can eliminate those when I add those together. I added 6x and 2x, I got 8x. I added 39 and 17, I got 56, not 58. Coach Sapp's an idiot. Okay, so the last step, I'm going to take 56 and I'm dividing by 8. I'm dividing by the coefficient, and I get that x equals 7. Again, the solution to my system of equations is a coordinate. It is a point. So the x value of my solution is 7. Now what I do is I take that, I plug it back in, either one of the two equations, doesn't matter, and now I'm solving for y. So I've got 6 times x, but we know what x is. We just found that x is 7. So 6 times 7 plus y equals 39. Now I'm solving an equation. 6 times 7 is 42, so 42 plus y equals 39. I need to get the y by itself, so I'm going to do the opposite of a positive 42, which is to subtract 42 on both sides. So then y equals -3. Solving by elimination. Okay, in order to be able to eliminate, guys, what I'm doing is I'm adding the two equations together. So in order to be able to eliminate, I need to get my variables matched up, and I need to have the same number but a different sign with one of my two variables. Same number, different sign with one of my two variables. Okay, so if I'm looking at number 3, my variables are not aligned. What I mean by that is the 7y, I need to have the 5y right underneath that. Here's the x, I need to have the x right underneath that. So I need to rearrange one of these two equations to where my variables are right underneath each other. Okay, so if it's me, I'm just going to take the top one. All I've got to do is I've got to move this x to that side of the equal sign. Because on this equation, the x is on the left side. So I need to get the x on the left side of this equation. Alright, so again, the way I move something in math is to do the inverse operation. So right now it's a positive x. I need to subtract x on both sides. So this now becomes -x plus 7y equals 32. So that equation is right there. I didn't change anything. All I did was move the x to the other side. I didn't change any numbers. All I do is move the x to the other side so I could get it right underneath what I needed to. I put the x in front because the x is in front in this one. I didn't move the 7y. It's still on the left side of the equal sign, so it's still a positive 7y. I didn't move the 32. It's still on the right side of the equal sign, so it's still right there. Now, once again, I'm going to solve by elimination, so I'm adding these two equations together. And again, the only way I can do that is that I have the same number but a different sign in front of one of my two variables, which if you're looking at your x's, you have it. You have a coefficient of 1, so the same number, but one of those is negative. So when I add those together, positive 1x minus 1x, those are eliminated, which again is what I am trying to do. That's the whole purpose of elimination. Eliminate one of your variables so you can solve for the other one. I've got a positive 5y and a positive 7y. I add those together, I get 12y. I've got 32, positive 32, and I subtract 8, I get 24. Last step, divide by the coefficient, solve for y. We know how to do that. We get y equals 2. So again, what we're trying to do is we're getting our coordinate, our point of intersection, which is our solution. So we just found that the point has a y value of 2. I need to find the x value. So take that, plug that puppy back into either one of your two equations. It doesn't matter. So I'm going to rewrite this first equation, but I'm not writing y. I'm plugging in what it's equal to. I've got 7 times y, but y is equal to 2. So 7 times 2 equals x plus 32. So over here you got 7 times 2, which is 14, equals x plus 32. Once again, we're solving for x, so I need the x by itself. So I'm going to subtract 32 on both sides. And I get x equals negative 18. So the point of intersection is at negative 18, positive 2. Now, could I have plugged it into this equation right here? Absolutely. Could I have plugged it into this equation right here for the y? Absolutely. It doesn't matter which equation you pick. This is the exact same equation as that. All I did was move the x to the other side. Okay, so it doesn't matter which equation you pick to plug it back into. I don't care. Pick whichever one is easiest. Looking at number 4, it's already set up to eliminate. Because again, I have the same number but a different sign. This is a negative 5, this is a positive 5. It's the same number, but this is a negative, this is a positive. Let's add them together because we can eliminate our variable right now. Negative 5x plus positive 5x, that goes away. We've eliminated that, which again is what we're trying to do. We're trying to eliminate a variable so I can solve for the other one. You've got a negative 6y, a positive 2y. That's a negative 4y when you add those together, equals 12. 8 plus 4 is 12. Now I'm solving for y, so I'm going to divide by the coefficient. Elisha, I hope you're getting this because I'm not seeing the pencil move. So then y equals negative 3. Again, we found the y value of our coordinate. We're finding a point. Our solution is a point of intersection. We're finding a point. Again, the solution is the point of intersection. So I know now that the y value is negative 3. I can take that and plug that back in and find the x value. So again, it does not matter which equation you pick. Do whichever one is easiest. Let's pick the bottom one. So I've got 5x plus 2 times y, but we know that y is negative 3. So I'm not writing 2 times y, I'm writing 2 times negative 3 equals 4. All I do is take this puppy, plug it back in right there. And again, why am I doing that? I need the x value of my coordinate. So when I plug in that y value, I have one variable, the x. There it is right there. Let's solve for it. So 5x minus 6 equals 4. 2 times negative 3 is a negative 6. Now to get x by itself, we're going to add 6, inverse operation. Add 6. That gives me 10. So 5x equals 10. Last step, divide by the coefficient, x equals deuce. All right, number 5 and number 6 are our special cases. 5 and 6 are our special cases. Graham, can you remember what two answers I get for our special cases? One is no,
No answer.
no, not no answer, no
Solution.
no solution. Okay, so one is no solution, rather the other would be infinite many solutions. Okay, so one is going to be no solution. The way I get no solution, if my two lines are parallel, they will never intersect. Again, the point of intersection is my solution. So I'm looking at where those two lines cross each other. Well, if they're parallel, they will never intersect. Therefore, there will be no solutions. If they are the same line, they lie on top of each other, which means they intersect infinite many times, which means there is infinite many solutions. Those are our two special cases. Hint, hint on number 5 and number 6. All right, let's go to number 5. So again, we're solving by elimination. So what I need in order to be able to solve by elimination is I need the same number but a different sign in front of one of my two variables. Well, if you're looking at your x, you have a positive 8x and a negative 8x. So you're Gucci. Let's go ahead and solve by elimination. We're adding those two together. So I have 8x, I add a negative 8x, or I subtract 8x. That is eliminated, which again is what I'm trying to do. So I'm left with one variable, the y. But when I add those together, guess what? Those go away also. Because a positive 11y and a negative 11y, those cancel out. So now you've got 4 is equal to 10. Okay, so Graham, is that a true statement or not? Is 4 equal to 10?
No.
No. Therefore, this would be no solution. No solution. And if you were to plug this into Desmos, you would see that these two lines are parallel, meaning that they will never intersect, meaning that they will not have a point of intersection, which is our solution. So if they never intersect, if they are two parallel lines, meaning they never intersect, they will have no solutions. Looking at number 6. Number 6 is not ready to eliminate yet. Number 6 is not ready to eliminate yet because you do not have the variables underneath each other. I need to move this 2x to the left side to then have it on the same side. Or I need to move this 2x to the right side to then have it on the same side. It doesn't matter which one you pick. I'm just going to take the top one and work. So I need to, again, move this 2x to the left side of the equal sign so it matches up with this equation. Because I want to write the variables right underneath each other. In order to move this positive 2x, I need to subtract it to that side. So I'm subtracting 2x on both sides. So this top equation is going to come down here and it becomes a negative 2x because I moved it to that side. So I had to subtract it to move it across the equal sign. Negative 2x, that y is still over there, so plus y equals negative 5. Okay, so what I did is I moved this positive 2x to that side so I could write it underneath each other. Now, I'm ready to add those together because what I have is I have the same number but a different sign. So I can eliminate the x's right now. Add those together. Positive 2x minus 2x, that goes away. I've eliminated the x's. Now I can solve for the y's. I've got a negative y and a positive y. Well, guess what? I eliminated the y's also. I have 5 minus 5. Well, guess what? I've eliminated those also. So over here you've got 0. Over here you've got equals 0. So Riley, does 0 equal 0? So this is infinite many solutions. Infinite many solutions. Infinite many solutions. Ryan, what does that mean? Infinite many solutions, Ryan, what does that mean? That means that they're the same what? They're the same line. They're the same line because they lie on each other. If they lie on each other, then they intersect infinite many times. Infinite many solutions. They're the same line. If you were to put both of these in y equals form, this is already in y equals form. Well, if I take 2x minus y equals 5, and I solve for y, I want to put it in y equals form, I subtract 2x on both sides, and I get negative y equals negative 2x plus 5. And then I need to get rid of this negative and make it a positive, so I'm multiplying it by a negative 1. It becomes positive y equals 2x minus 5. Well, that is the exact same thing as that. That's the same line. If it's the same line, it's got to intersect itself infinite many times. It's the same thing. Whereas on number 5, there is no solutions. There's no solutions. Andrew, what does this mean? If I have no solutions, what does it mean about these two lines? They're not equal. Okay, what else? They're parallel. Exactly. They're parallel, and they're not the same line. They're parallel, meaning that they do not have a point of intersection. Because number 2, 3, and 4, these are also not equal. But those are not parallel lines. If they're not parallel lines, they will intersect at one point, like the point 2, negative 3, or like the point 7, negative 3, or like the point negative 18, 2. Solving by elimination. Again, the only way I can solve by elimination is that I need to have the same number, but a different sign. So on number 4, I have the same number. They're both 5. But a different sign. This is a negative, this is a positive. So when I add these two equations together, that x is eliminated. And you're only left with the variable y, which in this case we have a negative 4y equals 12. And then I can solve for y. Once I have that coordinate, I can plug it back in and then find my x coordinate. So this is our last way to solve systems of equations. We learned how to solve by graphing, plug it into Desmos, find your point of intersection. We learned how to solve by substitution, which you redid on your do now. And then today we learned how to solve by elimination. Those are our 3 options for solving systems of equations. Now, does it matter which one you choose? Absolutely not. Absolutely not. You do whatever.